obviously that's what we're doing here. But there are some parts of this that you're going to need to look back at when you do the homework, okay? So, phones should be put aside, guys. Phones put aside. I'll put that back up later. Okay, so yesterday we did solving equations with absolute value. Today we're doing inequalities. It's pretty much the same idea. I think it's a little easier. It's like you don't have to do the checking, which was the biggest pain of it. Hello. That was the biggest pain of yesterday. You don't have to check these, but there is something different that you have to do. So first thing I want to tell you is that when we solve absolute value inequalities, so inequalities mean they have these symbols in them, okay? One of these 4. You have to rewrite the problem, kind of like how we had to rewrite the problem yesterday. So with these are called less than symbols, right? Less than. One of them has an equal to sign. But I changed the way you say less than with these. I call it less thans because I want you to remember that these are your and problems. Okay? Less than or less than or equal to, and to help you remember, think about it as less than. I know I spelled it wrong. I spelled it wrong on purpose to point out the and part. These are your greater than or equal to ones. I'm going to spell this wrong as well. Okay. Notice the or, great or, than. These are called your or problems. And that's memorization. That's why I give you the little trick. And that's pretty much the new part of what we're doing today. So just like yesterday, when you have an absolute value equation or inequality, you have to do the cleanup step first. Okay? So we have to get the absolute value symbol by itself. Sometimes it's given to you like that, like we saw in our homework the first few, and some aren't. And in this one, we have to get rid of the -5. So first step is to get the 5 to the other side. Okay? What are you doing? Okay, so once you clean up, you have to say to yourself, is this a less than or a greater than symbol? This one's less than. So what you're going to do is rewrite this. I hope you're not on your phone, Paris. You're not going to have a phone. I'm sorry? Okay, have mom not call you while you're in class or ask to excuse yourself. Okay, less thans are and problems. Less than, okay? Here's how we rewrite it, okay? Just like yesterday, you write it exactly like you see it. Remember, that was the first step yesterday. Whatever it looked like, you didn't change anything. Then we're going to put an and. Literally write the word and. Left side stays exactly the same, just like yesterday. Here's what's different. Flip the inequality symbol, change the sign. So changing the signs on the right-hand side, that's exactly what we did yesterday. If you remember, we just wrote it like we saw it, wrote the left side exactly the same. So that's always the same. All the different types is the left-hand side is exactly like that. The only difference today is you also have to flip the inequality symbol. Okay? And then we're just going to solve this 2 times just like we did yesterday. So I would add 8. And divide by 4. Okay? So for that part of the problem, we get x is less than 6. And let's see what we get here. I just brought that hand down. Add 8 to both sides. Of course, you can use your calculator. And divide by 4. There's the solution. We don't have to check it, but we do have to graph it. Easy graph. Really, really easy graph. You make yourself a nice little number line. It does not have to be perfect. It doesn't have to be spaced out. You don't need to do it on graph paper. When I have you guys make a number line, think about where these numbers would be. 6 would be over here. Let's call this -2, and then always put 0 on there. So I know where your numbers are in relation to 0. Clearly, I did not draw that exact. 6 is further away from 0 than -2, but this is just a sketch. Do not stress about that at all. We want all the numbers that are less than 6, okay? And we want all the numbers greater than -2. So what? It would be. Wouldn't it be all the you're on the right track. Wouldn't it be all the numbers to the left? Where are the numbers less than 6? It would be all those numbers. And it would be all the numbers greater than -2. Doesn't that actually cover the whole x-axis? Think about it. Let me draw it for you this way. Oh, one more thing I want to remind you of. We learned it already, but these would be open circles, and these would be closed. Remember when we did the piecewise functions, if you have the equal to sign under it? It's not going to matter on this problem, but if I were graphing it and I didn't know the final answer, open circle, I want all the numbers that direction. All the numbers that are less than 6 are, and I'm pointing in that direction. And I want all the numbers greater than -2. Where are the numbers greater than -2? Going that direction, right? When your number line crosses like that, it ends up being all real numbers. Or you could use our fun little symbol like that. Okay? So that's kind of a weird one, that one crossed. But sometimes they go in 2 different directions, which is fine. Okay? Wait. No, I said that wrong. I'm so sorry. Sorry, I was distracted. This is the answer, okay? And it's everything in between. Sorry, because it's an and. It has to be everything between 6 and -2. The numbers have to meet both criteria. You have to be less than 6 and greater than -2. So it looks like what's it called, a barbell, dumbbell? I always forget the word. But we have open circles on 6 and -2, and that's your final answer. That's it, right there, okay? And I'll come back to that idea because that will come up in another problem, all right? So think about peanut butter and jelly. Let's talk about that. If I went around the room and said, do you want peanut butter and jelly? It means you want both. If you say yes, you want both. It has to meet both criteria, peanut butter and jelly, okay? If it's an or problem, though, you only want one or the other, we'll come back to that idea. But and means both. It has to meet both criteria. So where are the numbers that are less than 6 and greater than -2? In between here, okay? So it just looks like that. That's the final answer, okay? Let's do another one. Let's do a greater than one, and then I'll do some from the homework with you. So you're starting to notice, especially now that we're not taking the notes out of the book, that I like to do, Isaiah, you should be paying attention, not on your phone. You should be writing, okay? You missed yesterday already. When I do notes, I try not to do a ton of notes. I have you guys engaged with me for a very short amount of time. I don't try to overwhelm you with a whole class period of notes, okay? Then I start the homework with you so we can do more examples together and get homework done. So when I'm asking you guys to be focused with me, I'm not asking a lot, okay? So please, 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 let's pay attention. All right, is there any cleanup in this problem? Yes or no? Yeah. What are we going to do first? -5, Mandy, right. Remember, when we're solving equations, and in this case it's like the first steps of solving an equation, we always add or subtract first. So I see a 2 over here. I'm going to have to deal with that in a second. But right now, I'm just subtracting 5. Okay? So I have the absolute value of 6x plus 3 over 2 is greater than or equal to 9. Right? Don't be afraid of fractions. Fractions are not scary. This is actually a fraction, but you could also think of it as what operation? Division. This is absolute value of 6x plus 3 divided by 2. What's the opposite operation of division? Multiplication. So we're going to just multiply both sides by 2, and that gets rid of it on this side. And now it's cleaned up. So everything I just did in that problem is the same first steps as yesterday, for anybody that missed it. Okay, we always do the cleanup. Okay, now we have to rewrite it. We have to rewrite it. This is greater than. Hear the or word in there? Okay, so here's how we rewrite it. It's going to look the same thing. If you're doing the same exact thing we just hear, except writing the word or in between. Okay, so that's 6x plus 3 is greater than or equal to 18. Just like we wrote yesterday, the very first thing. We don't change anything at all. Nothing changes. Because it's greater than, I'm going to write the word or. Yes, on this one we wrote and. Left-hand side doesn't change at all. Flip your inequality symbol. Change the sign on the other side. So the rewriting of the less thans and the greater thans are exactly the same. The only difference is the and or the or. And that can affect your graph, which we'll talk about, okay? So let's just solve these. I would start out by subtracting 3. And of course they have to give us a decimal. They love this. Divided by 6. Now, remember, the rule to know if we're allowed to use the decimal form, if I do 15 divided by 6, is that a good decimal or a bad decimal? Good, because it stops. So you can leave it at 2.5, totally fine, or you can hit math, enter, enter, and go back to 5 halves. Or, yeah, 5 halves. Either one. I think the decimal is easier, so I'm going to use that. So x is greater than or equal to 2.5. Or subtract 3 again. I have 6x, those guys cancel. Negative 18 minus 3 is negative 21. Divide by 6, divide by 6. Let's see what the calculator gives us. Negative 21 divided by 6. Negative 3.5, totally fine. Or math, enter, enter. You could use negative 7 halves. I, again, think the decimal is easier, so I'm going to use the decimal. Okay? But either one would be fine. Okay. We solved it. You don't have to check these, which is nice. You don't have to go back and plug in like we did yesterday, but we do have to sketch a number line graph. So don't overthink this. This does not need to be a lot of work. We have a positive number and a negative number, okay? And a 0 would be somewhere in between. So please don't feel like you need to draw all those lines and write everything in between. Oops, sorry. That's as good as you have to do. That's the most work you should have to do. Are these guys going to have closed or open circles on them? Closed, because of the equal to sign. Remember, it takes more ink to draw the equal to sign, so we have to use more ink when we put it on the number line. So, closed in circles at both of those numbers. And let's think about what this is saying. We have to be greater than or equal to 2.5. Where are the numbers that are greater than 2.5? To the right. And you literally just put an arrow. That's a visual representation of that. 2.5, including that 2.5, and all the numbers to the right, which are greater. Or we have all the numbers that are less than negative 3.5. So less than would be to the left. That's a really good visual representation. You can have peanut butter or jelly, one or the other, okay? So let me talk about one more thing before we go do some homework together. Remember how I messed up on this first one at first? If this was an or problem, you would say all real numbers, because it could mean any of those or any of those. When it's an and, it's very particular. And here's another idea. Let me say this. If this had been an and problem, the answer would actually be no solution. If this was your and, if this was an and problem, because you need numbers that fit both criteria. What numbers are in this group and in this group? There's none. Okay, there's no numbers that meet both criteria. Or is fine. You can have any of those or any of those. And has to have numbers in common. They should overlap. If your and problem goes like this, it's no solution. Okay, So think about what the word and means. Inclusive has to meet both criteria. You want peanut butter and jelly, but you're out of peanut butter, so I guess you don't get to have the sandwich. Okay? I always go too far with that stuff. Okay, let's go to page 79, which is the same page we were on yesterday. So if you ripped it out and you have it for yesterday's notes. Okay, page 79. We were up at the top, so if you weren't here yesterday, we did 1 through 6 at the top. Don't remember, you can go to Canvas to see the video, the notes, the key, all of that. Labeling your assignment. Remember, A17. We have a homework check later in this class period. I'm going to give you the assignment number. You find it. So let me start with you. What? 11 through 16. Sorry, 11 through 16. All right. Do you have this book? Ben, do you go by Ben or Ben? Ben. Do you have the book? What'd you say? I'm sorry. She hasn't used that book? Okay. I'll give you this. And just in case you're staying, I'll just give you, like, the pages. But I did ask. I said there's no reason for you to have to switch your math teacher for a third time. Okay. All right, so here we go. First thing is we clean up, all right? So we want to get the absolute value by itself. That's the first step. Okay, we have to remember that. All the different types of problems, we have to do that. So we get 2x plus 2 in the absolute value symbols. Yep. Yeah, it's just like when you solve an equation. How would you move a number from one side to the other? So opposite of subtraction is division. Okay, so this is a less than. Practice that in your head, less than. It's an and problem. So I'm going to write it just like I see it. Just like I see it. I didn't change a thing. And left-hand side stays the same. Flip your inequality symbol, change the sign of the number on the other side. Just like we did, in the notes. All right, and then we solve them. Okay, so it's just two. These are pretty simple equations to solve. Guys, when you divide anything by, if you divide 0 by any number in the whole world, it's always going to be 0, but you could ask your calculator. Just for space. So I have a 0 and a negative 2. So I already have 0. Those are the only two numbers I need to put on. Least to greatest. So I want all the numbers less than 0, greater than negative 2. First of all, we know they're both going to have a closed-in circle, right? Because of the equal to sign, that means closed circle. And we want the numbers less than 0 and greater than negative 2. That's the numbers in between those two. Most of the time, an and problem will look like that. Could be open circles or closed, but it'll have the segment in between. That means all the numbers between negative 2 and 0 meet this criteria. Okay? Less than 0 and they're greater than negative 2. Good? Okay, we're not going to be afraid of a fraction because a fraction is just division. Okay, think of it as division. No. So his question was, if you're writing it on your own paper, do you have to also write the answers on there? No. If you're writing it on your own sheet of paper, just know where it is. If I check A17, you just show me where A17 is. And I'll say it the other way around. If you are just writing the answers and you're not showing your work, that's not going to get you credit, right? There's work to show. Okay, so number 12, clean up, right? We can subtract that too. Greater. It's an or problem. Write it like I see it. No changes at all, except take the opposite value symbol off, right? Or, left side stays the same. Flip your inequality, change the sign. Ryan. Okay, add 5. X divided by 2 is greater than 13. Remember, x divided by 2, divided by. Opposite would be? Opposite of division, multiplication. You get x is greater than 26, or negative 8 plus 5 is negative 3. Opposite of division is multiplication. X is less than negative 6. So our answers, x's, can be greater than 26 or less than negative 6. So negative 6 would be to the left of 0 and positive 26 would be to the right. Ryan, you should be writing. Do you need a pencil? Let's go. We're already on our second homework problem. Almost done. All right, both of them will be open or closed. They would both be open. That's exactly right. Open circles. Okay, numbers greater than 26 would go that way. Less than negative 6 would go that way. That means any number to the right of 26 or the left of negative 6 would make the left side greater than the right side. You could plug any of those numbers in. It's not just one answer, like an equation gives you one answer. Inequalities give you a whole range of numbers. Okay, so these are like two-part answers. This is the answer, and the graph is an answer. Okay. Good gracious. I'm actually going to keep going with you. You're welcome. I want to show you something in these next two. So I'm really going to do all but 2 homework problems with you. Matthew, you aren't talking, are you? You're taking a test. Okay, so is there any cleanup in this problem? Any cleanup? Nope. We can go right into rewriting it. It's a less than problem, so it's an and problem. We had that. Okay, this is an and problem. Write it like I see it. We love it when there's no cleanup. And flip, change sign. Okay, and then I'm just going to solve them. -2 minus 5 is -7. Okay, so if I do -7 divided by 3, is that a good decimal or a bad decimal? Bad. I can't use it. Okay, I need to leave it like this, otherwise I'm rounding. Okay, but it is nice to know where that is for the purpose of putting it on a number line, right? Because I don't know where 7/3 is, but I know where 2.3 repeating would be, approximately. And subtract 5. Okay, so let's see what happens with this problem. They're both negative, okay, so 0's over here somewhere. -1 we can call there, and then, right, both of these would be closed, right? And then let's look. We want the numbers greater than -1, so that's this way, greater than those, and less than those. What numbers fall in both those categories? Somebody give me an example of a number that is greater than -1 and it's also less than -7/3. It doesn't exist because it has to meet both criteria. Remember, you want peanut butter and jelly, your family is out of peanut butter. You don't get to have a peanut butter and jelly sandwich because you said you wanted both. We can't make it happen. Ands have to have something in common. So you would say no solution. Another way of writing it is like this. That means like solution set is empty. There's no solution. Either way. Okay, so there's an exception to the rule. When an and problem goes opposite directions, it's no solution. Any cleanup on this problem? Nope. The absolute value symbol is by itself. That's what you're looking for. So we get to start writing it. Greater than, this is an or problem. So we write it like we see it with an or. Left side, the absolute value side, stays the same. Flip the inequality. And then change the sign of everything on the other side. That's like what we did yesterday with the equal, right? There was usually like a binomial over there. Okay, I need to get my x's together. What's x minus x? 0. Yeah. Is 0 greater than -1?
No.
Yeah. So you can kind of think of this as like a true statement. That's true. I mean, you don't have to write true, but that's just keep it in your mind. Look what happens here. We have x plus x is 2x. So we get this weird thing happening here, okay? What this is saying, guys, is any number you plug in here will work. Okay, there's absolutely no number that you could use here that wouldn't work. Because think about it. Just think about it. Pick any number. Pick 10. If I put a 10 here, absolute value of 10 is 10. Is that greater than taking that same number and subtracting 1? Of course. So any number, any x value would work here. That's why in this problem, can you guess, because it's kind of weird, it feels weird, what do you think the solution is? This is in all real numbers. We want any number plus or all the numbers less than 1/2. It's just all real numbers. Again, you could use that symbol. There's no graph to make because it's really every point on the number line. So you don't even need to graph those. Okay? I will put 15 and 16 up. You have plenty of time to get those two done. Yeah. Who am I answering? Who asked that? Okay, I'm sorry. Anytime, and we're going to see this again in other types of problems coming up here soon in the next couple weeks. Anytime your variables are taken out of the problem, like this, when they are canceled out, you're either going to have an answer of all real numbers or no solution. It boils down to, is this a true statement or a false statement? It's a true statement, right? 0 is greater than -1. Do you agree with me? And here's the proof. Like, pick any number in the whole world. Like, let's use x as 100 and plug it in. So if I put 100 there, the absolute value of 100 is 100. Is that going to be greater than 100 minus 1? Always, because you're just going to subtract 1 from whatever you had in there. So any x value will make this true. And it says or. So we want any number in the whole world or a number less than 1/2. Well, this is covered in all of these, okay? So I can see that can be a little confusing. Let me just finish writing the answer to 15 and 16, and then I'll put it up. So I didn't show the work, but there's the answers to 15 and 16. And I might have the order backwards. It doesn't matter which one comes first and which one comes second, just so you know. It does not matter the order that you write them in. As long as the symbol goes the right way and all that. I am going to be checking this. Let's get it. Matthew, do you want to see the notes? Okay, or it'll be on Canvas if you'd rather. Okay, so keep working, find A15. When I come around, I'll check it, go back to work. Don't just sit there and wait for me. You know it takes me a while to get around the whole room, check homework. So A15, which was the test review, so it was a worksheet. I'm going to check that.
I got
Find it. Let me know. Don't forget about Albert I.O. guys. Mm-hmm. It was written at the top of the homework number. Of the notes, I mean. Albert I.O. guys. So then I had both of your brothers. You have two, right? Troy and Aaron. I don't think I had Joseph, but I do remember hearing that name, so I know. I did email her. Yep. She hasn't responded. She's usually pretty quick, so I wonder if she's out today. She's usually pretty responsive, so let's give her a chance. Actually, I'm going to forward that email to him right now, too. You have lunch now, obviously. I would go up to him. Like, he's... Okay.
It's just, it's not like
It's a lot easier. So...
have any enthusiasm.
What?
Have any enthusiasm.
You can't?
Yeah.
Why?
I don't know.
You don't like it?
It's like an old, boring. So I'm gonna take this, put it here, put it there.
Ooh, it's Miss Fallback? And you like that or don't like
I
it?
love it. I'm
Why?
serious. I love it.
I believe you, but like, I don't get why.
I picked up things a lot quicker than we're kind of doing the same thing in her class, but I think,
She's missed a lot of days, right?
yeah, I know, I think we're still on piecewise function. So you said that, and I was like,
And I did say that. I said I think we're ahead of where she is, so the student would have to catch up. You know what I mean?
tell them I'm stressed out, too.
I did say that,
Nice.
and so, and I'm going to tell Mr. Bernstein that too. But you need to say it. So I would just say, you know, how he stands out there during
Yeah,
lunch.
I'll probably
and just be like, this is it's not fair. I don't want to have a third teacher. You know, nothing against Miss Morris. You can say that. Okay. Yeah.
What's going on about that? Huh? No. Not like that school. No, wait. Not $50. Alright, thank you, Miss
All
Morgan.
right. He might get it done quicker. So.
Okay.
Like Harmony? Yes. No way. She walked by the wall and then stopped.
Don't say that.